Hello everyone, welcome to the course Applied Artificial Intelligence. Today our topic will be creative AI, which is really interesting because if you think about it, so far we've dealt a lot with the deterministic ways of AI, right? It was about predicting failures of machinery, for example, and now suddenly we're talking about something entirely differently, creativity. And it's a really interesting development because by now you can see how AI is able to expand creativity. It can create art, music, stories, solve problems. It basically pushes the boundaries of what can be done, as you will see as part of this lecture and as you might have experienced yourself already. It's also redefining roles, right? What is the involvement of a machine like AI right now in processes, in innovative processes, and specifically in creative processes? And this can, of course, lead to shaping entire industry, transforming areas like design, entertainment, marketing, and influencing how work is being done in these areas, as well as the cultural impacts of that, challenging ideas of originality, of authorship, and the role of artificial beings in creative processes overall. And this also, of course, begs the question of the responsible use of these technologies, but we won't do that today. This will be part of the ethics AI one. No, today is all about creativity and AI. And I want to start with two examples, which we'll discuss in depth in class. But you can see two different pictures here. Well, in fact, these are four, but two of them are AI generated and two of them are real pictures. And what you can observe here is that it's becoming harder and harder for us to distinguish between those cases where something is AI generated and something that is generated by a human being. And I want to make this point very explicit because the examples from here are 10 years old by now, right? So this is stuff that could have been done even 10 years from now. And if we think about the recent advancements, which we'll cover in a second, you can see how far we've come. But we'll take this riddle to the in-person class. In the logic of our story today, we're coming towards the end and we're discussing important topics of AI. To be honest, that don't really fit in all of these categories of the AI lifecycle of AI in systems. But on the other hand, it has an impact on those. Everything that we learned in the AI lifecycle has an impact on how we design creative AI. And on the other hand, creative AI also has an impact on this lifecycle itself. Same applies to AI in systems, specifically the utilization of foundation models, learning across different styles of creativity, and of course for human AI collaboration as well, because the creative aspects of AI influence how human and AI work together. So, what are the objectives for today? First, I want you to discover what does creativity mean, and especially what does it mean in the context of AI. And in order to do that, we need to second understand what is that phenomena of creativity? How can it be differentiated, right? Entirely regardless of any AI capabilities, what is creativity in the first place? Third, I want you to intensify your knowledge when it comes to the aspects that AI can cover in creative processes, in creative thinking. And finally, I want you to be able to discuss some recent examples on how AI can be creative. And as a result of these objectives, we can look at the agenda where we will first talk about what is creativity, what are aspects of AI that relate to the required fundamentals of creativity, and then finally, what does this combination of AI and creativity lead to in very modern examples. So let's start with the first one. What is creativity? And the interesting aspect here is that we now go entirely away from any technology, from AI. Let's have a look at creativity by itself. And it definitely is a complex term, and there are many definitions, and we'll cover a few of those right now. But let's start with the most basic question, that is, what does creativity mean? And there's a very nice quote from Stein here from 1953, which I just read out by now. So the creative work is a novel work that is accepted as tenable, or useful or satisfying by a group in some point in time. By novel, I mean the creative product did not exist previously in precisely the same form. It is necessary to distinguish between internal and external frames of reference. Right, so what does that mean? I find it particularly interesting that it means something is accepted as useful or satisfying by some group in some time. And that is a very, very interesting aspect, because that means that this is a certain point of reference that Stein is also referring to at the end of the quote here. There are many, many famous artists who gained only appreciation after their death. So at the time where they created their work, they were not being seen as satisfying any needs or being perceived as useful, but they were in a later point of time, right? So Vincent van Gogh, for example, he was often criticized for being too dark and lacking in energy, but his whole fame came after his suicide in 1890 by his sister-in-law, who preserved a lot of work and made sure that it was appreciated later. One of my most personal favorite authors, H.P. Lovecraft, he made a spare living working as an author and as a ghostwriter, to be precise, rarely sufficient to prove a real living during his time. And it wasn't until the 1950s and 1960s, well after Lovecraft's death, who died in 1937, that the author really picked up on, other authors really picked up on his themes and his style of writing, right? So I think it's an important aspect to look at this time component. But in a nutshell, it means something is creative when some group of people find it useful in some point of time. And it didn't really exist in exactly that form. And that's to be debated what that form is, right? We'll get to that in a second. There's this idea that we can describe creativity around the creative piece, the creative product, the creative process, the creative person, and the creative potential, right? And especially when we look at the creative process, it's important for us to be aware that there are two types of creative processes here. One is the unconscious process, right? These are things like intuition or incubation, right? Incubation is the process where you need to think about a certain problem a longer time, and you suddenly have that core thought in the shower or while drinking coffee, while your mind processed and thought about the problem that you're trying to solve. And then, of course, there's the conscious creative process, right? So stage and or component models, and there are two famous ones. The one is the stage model, which says that every creative process looks like that, right? You have a preparation phase where you look at the problem, and then you have the incubation phase where you think about it, and then you have the illumination, which I just talked about, and then finally the insight, right? These are the stages of creativity if you want to fit it to a very linear model, right? This is, of course, debatable, but that's how you can do it. And on the other hand, you have the component model, which says, well, three things come together here, right? The component of expertise, the task motivation, and the creative skills. And once these come together, you can be successful, right? So this gives us a first insight into what creativity is. But creativity is also, if we look at human creativity, is also heavily linked to the cognitive abilities of a human. And you can see those over here, right? These cognitive abilities determine the individual creativity, right? So that's what you see on the left here, right? Of a single person. So it's your ability on divergent thinking, on combinatorial thinking, on how you can restructure things, on how you can transform one thought to the other, how you can abstract or generalize from a single case, how your analogical thinking is, and how your associative theory is. And all these things come together and determine your individual personal creativity as a human being. The interesting thing, however, is that apart from these authors that we looked at, like Lovecraft or like Van Gogh, obviously in many, many cases, people are creative because they work together. Now, what we want to do now is let's increase the amount of people involved in a creative process. So let's say we look at dual creativity. Now, it's not only about the cognitive abilities of this single person that you can see on the right here, but it's about the team qualities of two people working together, right? So a combination of the cognitive abilities of these two working together in dual creativity. And if we further increase the amount of people involved here, we come to group creativity, right? So it becomes more important who covers which part. And then finally, we have something like crowd creativity with large collaborations, right? Where large collaborations are possible. And how this is done, we'll see in a second. But let's first look at the individual creativity, right? You can see the cognitive abilities that are important here, but let's also have a look at the factors that influence this individual creativity. And there are a bunch of them, right? The one is, of course, your personality, right? Your traits, your interests, your attitudes. But it is also your knowledge on the domain, on the specific problem that you're working on, your technical skills that might be required if it's a coding task, for example. The environment is immensely important, right? What is your social context? What's the climate, right? What's the feeling in that context? What is the task context? Well, how complex is it? And then, of course, the cognitive and thinking skills that we just had a look at. But other things apply to that as well, like the flexibility of your mind. How well are you in remembering accurately, for example, what someone else said, what the task was, and how well can you analyze, right? We can look at the previous slide for more on these skills that are needed. And then finally, of course, the motivation, both the intrinsic but also the extrinsic motivation. And all of these factors come together and they influence your individual creativity. And if we look at how you as an individual now approach something, you can see that these capabilities are put into action. One way to look at this is look at again at this stage, the stage process of creativity, which means first is the problem finding, the task presentation, right? What is it that you're trying to do here? And you can see how this is influenced by the motivation, by the knowledge and the cognitive and thinking skills below, right? Especially when you start something, motivation plays a very, very important role at the very beginning. Number one over here. Second step was the preparation, right? So you build up the relevant information that you need in order to solve that problem, right? And this is where your knowledge comes in, right? This is also where your cognitive and thinking skills come in. And then you come into the ideation phase, right? This is a divergent phase where you generate ideas. And what you then do is you evaluate these ideas, which is the best, which fits the problem that was originally trying to solve, and then come up with a final solution. And again, your motivation, the knowledge that you have, and your cognitive and thinking skills, they influence all of these steps above. But this also means this all relies on you as a single person, right? That was the idea of the individual creativity. Now let's see what changes when we start working in groups. Let's say again, we look at dual creativity. And now what's so interesting is that creativity is now not determined only by your individual abilities, but by the ability of the group, even if it's only two people in this case, right? So it's the individual abilities, but also the environment. Because we only have two individuals, this means we have a greater intimacy and potentially a psychologically safe environment, right? You have mutual trust, affection, and this leads to a few effects. On the one hand, if we work in dual creativity, we increase the diversity, we increase the feedback, right? Before it was only one person thinking and evaluating and generating the ideas. Now you can think about that in a small team. On the other hand, you also introduce negative effects when it comes to group creativity and especially dual creativity. First being the evaluate apprehension, so the fear and anxiety that individuals may feel about being judged or evaluated by someone else, particularly in these creative settings, right? So because we are trained in social rewards and punishments and approvals, it's important to us how other people perceive us and how they evaluate us. And this is a negative effect that will get introduced once you work in a dual team. And also you have the pressure to conform, right? In terms of like, okay, I believe that the other person really likes this idea. Should I conform here, right? So by moving from a single person to two people, things obviously change. And also the creative process changes, right? It could look something like this. Person A discloses an idea, and then person B further elaborates on that idea, and then person A and B further evaluate that idea or keep developing it, right? So we can see the creativity is now determined by different things, and also the creative process itself looks differently. Let's further increase the amount of people involved. Let's talk about group creativity. Now, the creativity is not only determined by the environment and the individual abilities, but also by the group abilities. And new things come into play here, like the integration skills of all the people involved, the emotional intelligence of these people, and also the trust in the group. This also means the process looks a little bit differently, right? It's now a lot more about inspiring, collecting ideas, creating them, organizing them, evaluating them, and then selecting them and distributing also this type of work. And the consequence of that are, again, both positive and negative, right? You have even more diversity now. You have even more feedback mechanisms in place now. But the evaluate apprehension and the pressure to conform, they both also increase, right? That's something that you have to think about when you distribute creative work to teams. And now, the final case of creativity in groups is crowd creativity, right? So hundreds or 50 or more people working collaboratively on a creative task. And again, it's interesting because things change here, right? The group abilities like emotional intelligence and group trust, they're less important because people are now more anonymous in these groups, right? You still have the upsides of increasing diversity and feedback, but you introduce a new negative thing, which is the free rider syndrome, right? That people just ride along, but they don't contribute to the overall idea. And if you want to design a creative process in such large crowds, you can see an example on the left here, right? Like one crowd generating ideas, for example, 100 ideas, and then the second crowd selects the best ideas, and a third crowd generates new ideas based on those selected ones, and so on and so on, right? It's really interesting how you can design these large crowd interactions, and this is also something that's typically done then online via own platforms. So really, really interesting case, as you can see. Why am I talking about that? Because obviously what we want to think about next is, where could AI help? Which role could AI take in all of these cases, in individual creativity, dual creativity, group creativity, but also crowd creativity? So think about that right now, right? Where do we see AI in this logic of creativity? Right, so that's about as quick as we could do it, about the foundations of creativity, but we need to cover them because now we want to look at the aspects of AI again that could help in being creative. So, quick recap on the important aspects of AI when it comes to creativity. First is the problem-solving ability of AI, right? Recall the first lectures that we have, defining a goal, success criteria, and so on, right? What should the solution look like? What are the constraints? For example, if we look back at reinforcement learning, this means an agent could deliver certain actions depending on a prior state, right? And these problem-solving abilities are important because, again, we want to tackle a problem, a creative problem potentially. The other important aspect of AI is, of course, knowledge, which is the basis for decision making and can be generated in different ways. But having a storage of true or false information of our world, of our domain, of the specific creative style, for example, if we're in that domain, is really, really important. And third is uncertainty. And this uncertainty aspect becomes really important. Also, a randomness becomes important when it comes to creativity. We talked about different options that you have, right? For artificial neural networks, for example, you can utilize Monte Carlo dropout as a measure there, right? So these aspects of problem solving, knowledge, and uncertainty will become important in creative AI. The other aspect is, of course, how is that knowledge generated? By learning. So the ability of AI to learn from examples, and then taking this knowledge into account, updating those models, remember our concept drift discussion, is really, really important. And then finally, if we look at any kind of creativity, even if it's individual, in the end, your results need to be communicated, but that's also the case for especially dual and group creativity, is the means of communication, right? Working with natural language processing is really, really important. And we covered this as part of the lecture, right? So you can see AI fulfills a lot of aspects that are required to be creative or to work in creative groups. And one thing that we also have to shortly recap is the level of intelligence here, right? Because there are two cases, if you recall the definitions, and if we look at the Turing test again, of strong and weak AI. Just to repeat that, weak AI or narrow AI is an AI that can execute certain tasks very intelligently, potentially even better than a human, but it would not pass a Turing test, where, however, a strong AI or an AGI can complete any task that a human does, completely mimic them in their behavior across all the aspects, right? Like with scientific wisdom, creativity, social skills. And of course, when we think about the distribution of creative tasks, it becomes important to notice what kind of intelligence level are we dealing here with when it comes to an AI agent. Is it weak or narrow AI, or is it strong AI? Now, with that at hand, let's have a look at how AI can be creative from a technical perspective. And the most important foundation that was laid in the 2010s, 10 years, was the concept of generative adversarial networks, or short GANs. And that was the main way on how AI was able to be creative. Because again, if you think back on everything that we learned on supervised learning and so on, while that was not 100% deterministic, it's really hard to imagine how these models can be creative. And generative adversarial networks address exactly that. And their setup is rather simple, as you can see over here. So you have a generating network that can create impressions, and those impressions are forwarded then to a discriminating network, which assesses, which evaluates those impressions that the generating network produced, right? So the generating network is the creative part here, and the discriminating network is the realistic one. And it's so interesting because that's a great case for dual creativity, only both of these creative parties involved are synthetic here. So two intelligent entities cooperate, one generating ideas, one discriminating these ideas, and then only those cases where the discriminator network thought that is a good case will be led through as the final product. And a great example of that is identifying real or fake images, videos, speech, whatever, right? We have a generator network which feeds in random noise and generates images, and these images are then determined by a discriminator network which also has access to real images from a training data set. So it does know how our world looks like. It does know what certain types of images look like and try to identify, is the generator fooling me or not? To give you a more precise example, how is this being done? You have the generator on the left down here, right? So this generator starts creating images, fake images, of course. And the only way for it to be creative here is to add random noise. So it might have knowledge on a few images and will add random noise to that, and then these are forwarded to the discriminator. Now the discriminator was trained on real images, like numbers, for example, right? And it will now try to determine whether the output here is real or fake. And those that it determines to be real are being passed on. And by that, GANs can be creative, or their result is many times perceived as being creative. That's the one way of doing that. Now, these models got more advanced over time, and how it's done typically right now, especially with images and videos, is by using denoising diffusion probabilistic models, or short DDPMs. And they're a class also of generative models like GANs, but they work a little bit differently. So they work by starting with a sample of random noise and gradually denoising it through a reverse diffusion process to then generate a sample from the data distribution that it originally had, right? So you have two main phases. The forward diffusion in the beginning here, that's this one. That is the noising process. So this is where data, so a real image that you have, is gradually corrupted by adding more noise over a series of time. And at the end of this process, the data is transformed into pure noise. And then in the second part, you reverse this diffusion. This is the denoising process. So you start with the noise, and the model now attempts to reverse the diffusion process by learning to denoise the data through a series of steps. And then in the end, you come up with something differently. And on that basis, you create new types of images, new types of videos, or specific images and videos that you wanted to design in the first place, where you gave it clear instructions. And that's a very, very typical way on how AI can be creative right now. Now, in the next step, now that we covered creativity and roughly went into how that works technically, let's have a look at interesting combinations of AI and creativity. Now, historically speaking, there was even a specific term for when intelligent agents can be creative, and that was framed as computational creativity, right? This is a field that has tremendously changed in the past years, but it's interesting, I think, to look back at the roots. So if you look at the 2012 definition that says computational creativity is the philosophy, science, and engineering of computational systems, which, by taking on particular responsibilities, exhibit behaviors that unbiased observers would deem to be creative. And this refers again to our definition of creativity at the beginning. And if we look at the map of what computational creativity can be, we can find evidence of that also in our more modern examples, right? In games, in the design of games, of players, of non-playable characters, and so on, in visuals, images, painting, collages, in evaluations of creative work, conceptual ideas, in music, in linguistic, and so on, right? So this idea of that computers can be creative is nothing new, but we do see new possibilities with the recent inventions in AI research. And when it comes to the assessment of computational creativity, there are three different approaches that should be named here, which refer to three authors and different viewpoints on the evaluation of computational creativity, which are Koza, Ritchie, and Colton. And they emphasize different aspects of creativity. So Koza focuses on the creative process, right? Evaluating how well an AI system can mimic human problem-solving skills, idea generation skills. So it emphasizes a lot the method behind it, how are innovative algorithms used, or which novel techniques are utilized here, right? Mimicking the human, mimicking the process. Ritchie has a different view on that. Ritchie says, we center on the output of the creative system. We do not care about the process. We just look at the output itself and value that, typically based on predefined criteria. So uniqueness, usefulness, right? The key properties are the quality and the novelty of what comes out. And then we have Colton, which looks at the creativity tripod. So skills, imagination, and appreciation. So it not only looks at the output, but the ability of the system to explain itself, to justify its creative positions, you could say, right? And I'm not saying that any of these three authors is right or wrong. These are just different kinds on how you can evaluate computational creativity. Okay, but now let's have a look at interesting combinations of AI and creativity. And one of those you saw very early on. That was the first image that I showed to you, where I showed in fact two Rembrandt paintings, and one was a real Rembrandt painting, and then there's this painting over here, which is a project that is called The Next Rembrandt, and that is an entirely AI generated image, but in the style and in the idea of the famous painter Rembrandt. And how the team did that is they gathered information from existing Rembrandt paintings and then created a new painting based on the learned features. So let's have a look at this in more detail over here. What they did first is they gathered the data. So they distilled the artistic DNA of Rembrandt by utilizing an extent database of his paintings, analyzing it pixel by pixel. Next, they determined what the subject would be. Right, so they recovered data from Rembrandt's body of work and showed the way to the subject of the new painting. And then finally, it was all about generating the features. So a system that could work with facial recognition algorithms was designed to understand the precise style, right? And then it was brought to life. So they first generated a 2D image, and then based on that, once that was complete, a height map was created that you can see on this very last frame of the video here, which really mimicked the brush strokes that Rembrandt did in his painting. And that was a widely acclaimed, widely successful example of what AI can do. Of course, with still a lot of human involvement, but the main parts were done here by AI, determining the subject, generating the features, so the 2D painting, and then bringing it to life with the mimicking of these brush strokes. Really, really interesting case. And that was one of the first showcases which really showed how far we've come with AI. And it's already a few years old, right? So I think that's really interesting. That's one example. Let's have a look at another one. Let's move from paintings to music. Also, rather old idea here, back from 2018, but an interesting one nonetheless. The Universal Music Translation Network. So the basic idea is here to mimic any possible music style. So if you have an existing piece of music, you can transform it into a different type, right? So Haydn can sound like Mozart. And let's have a look at the result over here. And what you will see is that there were parts of music that were in training and some were out of training distribution. Okay, I'll pause here for a second. So what you can see is how one piece of music was transferred into very, very different styles. Now, what's interesting is that I think that sounds rather well. And again, we're back in 2018 here, so that's impressive groundwork. But what's even more interesting is that they will next try parts that were not part of the training, right? So the piano of Beethoven was part of the training. Now let's move to a case where someone is whistling as an input. The system was never trained on that. And let's see how it works with that. Okay, you get the idea, right? Very interesting work. It's cool to see how you can transform instruments and in entire styles, and more details on that are part of the paper here. Let's stay in the field of music and look at more recent works. And there's this framework called Get Music, again a scientific paper, as you can see from the reference below. And the idea here was to generate entire music tracks from scratch, either by conditioning existing text or taking adjusted ones. And let's have a look at an example here. So that is an entire piece of music now generated from scratch with different instruments, and you can see all of them as we go through it. Let me play here. Okay, so you can see rather complex music sheets, multiple instruments, and everything is generated from scratch. So very interesting case. A lot of this goes back to ideas that also formerly came from Google. And one of the things that I found most impressive is the Google AI duet, which is also, again, rather old by now, but it's interesting showcase. And I specifically like that example because it goes back to our idea of dual creativity. But let me just play it out for you so you can have a look
Hi, I'm Yotam. This is an experiment called AI Duet. It uses machine learning to let you play a duet with the computer. Making music using code isn't a new thing at all, but machine learning gives us a different way to go about it. If I was trying to make AI Duet with more traditional programming, I'd have to write out lots of rules, like if someone plays a C, maybe respond by going up to a G. Or if someone plays 3 ascending notes, then maybe go back down. I'd basically be creating this map to tell the computer how to make these decisions, but there are just too many note and timing combinations to map it all by hand. This experiment approaches the problem differently, using machine learning, specifically neural networks. We played the computer tons of examples of melodies. Over time, it learns these fuzzy relationships between notes and timings and builds its own map based on the examples it's given. So in this experiment, you play a few notes. They go to the neural net, which basically decides, based on those notes and all the examples it's been given, some possible responses. I had some friends try it out. It was fun to see how it responds to different things people play. It picks up on stuff like key and rhythm that you're implying, even though I never explicitly programmed in the concepts of key and rhythm. It was cool to see people use it in ways I didn't expect. Instead of taking turns, a few people played at the same time as the neural net's response, kind of getting in a creative feedback loop with the computer. It's also fun to just mash the keyboard. The neural net tries to return something coherent from any input that you give it. I made all of the code open source, and the neural net that I'm using is from Google's open source Magenta project, so anyone can grab it and train their own net. I wanted to put this experiment out there just as an example of the many kinds of things you can make with machine learning and music, and I'm really excited to see what other people do. You can play with it at g.co/AI experiments.
And what I particularly like about that is this creative feedback loop that he's mentioning, right? You get in this dual creativity mode of two entities collaborating with each other, being creative and producing music in that case, whereas one of those entities is a human being and the other one is a synthetic one, an AI in this case. So very interesting case. Now, let's have a look at a very recent example, Zuno AI. I don't know if you've heard about them, but it's cool because they give you a bunch of options, right? You can enter lyrics, and potentially those can be obviously generated with other Gen AI tools. You can select the style of the music, whatever you want, guitar, rock, a title, change those, and then it will create an entire piece of music. It's not entirely transparent on how Zuno AI does that. So they do say it's a combination of deep learning techniques, including recurrent neural networks, convolutional networks, and transformer architectures. But the precise design is unknown. And the output is rather impressive, right? So I give you one example that we see on the right here. This would be the city lights cades, so electronic music, drum and bass, and a little bit of psychedelic elements.
Night falls on the city, shadows start to dance. Underneath the lights, we move without a glance. Twisting in the moonlight, feet above the ground. Music in our hearts, lost, but now we're found. Oh.
So I guess you get an idea on how powerful it is, and it's really interesting to try that out for yourself to see how far we've come also in the history of starting with very basic ideas on how you can create musical pieces with AI up to this piece of work right now in the end. Let's have a look again at different case of creativity, images again. We saw the Rembrandt in the beginning, and this is also the solution to the riddle from the first page again. Another case of generating artificial paintings. And that's a project also back from 2015, which had the idea of transferring the style of a single painter, in this case Van Gogh, if you haven't guessed by now, to another image. and they tried that with convolutional neural networks. So the idea is to learn the style of an artist and then apply that style of an artist to any raw picture out there. So you have Van Gogh over here, and you have a picture of the city of Tübingen. And what they did is they slowly reconstruct the content by adding the style reconstructions that you can see above there from Van Gogh through each of these convolutional layers. And over time, this transforms this raw image into the style of another case. Really interesting work, which you also can try out by yourself. And this means we can teach these systems certain styles or representations that can then be implemented for other cases as well. Another interesting case is the idea of creating entire images from text, right? This is something that you're used to by now, but the foundations again go back to GANs, and especially to this paper over here from 2017, which did the first attempt of having a text and generating images based on this encoded text. So at first, the text is encoded to read information from it. So in this case, it's about generating birds, right? So we have the description of the bird above there, and now we get the semantic vectors out of this text description, right? Information on the head of the bird, the color of the bird, the beak of the bird, and so on. And then an image is created using already learned images. So the system has an understanding of what bird looks like, and then make sure that it's fitted to this original description. You can have a look at this complex architecture, and we won't go into detail, but the most interesting thing is that you have a generative network in the middle, and that the resolution is increased over time, right? So you start with an image of a lower resolution, which gets then increased higher and higher if the model is successful in creating an image that corresponds to the encoded text in the background. And the authors provide a bunch of different examples on how that works, right? So we have different types of birds, in this case, one with a yellow crown, one with a green crown, and so on. And you can see how the representation of the text is then implemented in the precise pictures and which areas are highlighted there. Really cool to look at. And what they tried out, but that was more of a fun part for them, is also to do it on other things, right? It was never trained for that explicitly. It was built for birds, but they also try to do this with other things like food, right? You can see swirly pasta over there, or a fruit stand. I mean, you can see it doesn't work as well, but the general idea, of course, is working really well. And this was the groundwork for many other cases of image transition that have been done. As a similar example to transferring the style of music or transferring the one of the Van Gogh painting, there's also this nice paper, which again uses GANs to transform an image of someone into a comical character. As you can see, or like a Disney Pixar character. You can see examples of that over there. And by the way, by now that is like a product that they develop and that you can pay for. So out of this pure research project became something like a cartoonification tool that can be used right now online. Again, if you're interested in that, try that out. But it's not only about transferring the style from one direction to the other, but also to utilizing GANs to always come up with realistically looking images of people in that case, right? So when you adjust a pixel over here in this editor, right, something like a Microsoft Paint editor, it will update the image so that it has a coherent output, as you can see there, right? If you change small parts, it will change the entire hair color, it will change the entire appearance of that person, to always make sure that a consistent output is generated, again, based on GANs. And you can push this even further, as you can see in this example over here, where we can change the dog, change the nose, change the legs, the ears, and it always will result in a meaningful, coherent overall picture, right? So, I mean, look at that for yourself. I think that's pretty interesting. And you can see it works with animals, with cars, right? With all images where enough data was available so that the tool can make sure the output is meaningful. So you can see this works with people. One of my other favorite examples here is the thispersondoesnotexist.com website, which will generate entirely artificial faces. So these people factually don't exist, but they look very realistic, right? If you look at the skin, for example, it has features that were in the past very, very hard for AI to do, right? As you can see on the forehead over here, or these cases over here. So again, really fascinating what can be done. Again, because the system understands what a real world person looks like, and then makes sure that the output is evaluated against that logic. And of course, what you can do is, and this is no news to you, is generate entire images based on text artificially. And that's where we utilize these diffusion models that I talked about earlier. And there are tools like DALL-E, GPT, Midjourney, right? You're aware of that. There are many, many interesting cases of that. But it's not only images that you can generate, but also videos. And that, of course, gives you a lot of ethical, moral considerations as well. So let's take famous personalities and let's have a look at an example over here. So over here, that's an entire video generated based on so-called deepfakes, right? And of course, this can have troubling implications. Let's have a look at what that looked like over here in this case. Now that's from a movie called Step Brothers with Sylvester Stallone and Arnold Schwarzenegger. And what the authors here did is they simply exchanged the two faces. They did exchange Will Ferrell and John C. Reilly, who were in the movie originally, with both Sylvester Stallone and Arnold Schwarzenegger, who never were in that movie. So let's have a look at that. Okay, you get the idea, right? While it's not perfect, it pretty much gives you the main facial features of both Sylvester Stallone and Arnold Schwarzenegger over here, and you can't see the necessarily where it came from. Like the original actors, Will Ferrell and John C. Reilly, are not identifiable here anymore. So again, something for our ethics and fairness discussion, but things to think about. And this is obviously something that will be seen more and more frequently. Now, let's have a look at a different example again. So, and this is also kind of a summary, you could say, at this point. So we've seen many combinations of creativity in AI now in creating images, in creating videos, music, and so on. That was all very impressive. And if we look at also the past lecture that we we looked a lot on how AI could be utilized to make things more efficient. But what we could see from these examples over there is AI can also inspire people, right? It can take this certain part in the creativity process where it's about inspiring, about divergent thinking. And there you can find examples also in business tools, things like Notion AI or GitHub Pilot, things that you might have experienced yourself already, right? Where you can use these to generate entire functions when it comes to coding, where you can give it precise tests that it writes for these functions, right? To make sure that this piece of code works over time when also other environmental aspects change. So to me, this is one of the very, very interesting implications of creative AI, right? It's nice to create images and create text and so on, but now AI's role shifts a little bit. It's not only about making things more efficient, but also about inspiring people and helping them in daily tasks, and which is definitely something that I'd like to discuss with you when it comes to our in-person discussion. But it's not only that. I also want to give you a final example of research that we do, because we believe that you can use these creative AI functionalities based on generative AI in many other cases as well. So we have an example over here where you could use synthetically generated videos for surgical training, where you could simulate certain situations for the clinics, for the physicians, right? You could tell them which situation you want to simulate via text, then use the diffusion models, and then generate images of these situations. Because, of course, these videos and these images are very, very rare because they're health data, and obviously they are treated with a lot of regulations. And that's something that we've been working on. How can we generate these videos for surgical training? And we started with images, and we gave those to a bunch of clinicians to see whether they could detect if that was AI generated or not. So whether this came from an AI tool or it came from a real image of that surgical task. And the next step is obviously now to work on the video. So once you're successful on the image, the next step is then to use a video. And you can see how the different tool positions are utilized here and how they're then translated into a real video. But that is, again, ongoing research and just a look into how creative AI can be utilized. Which brings me to the final slide today, is on the question of how creative is AI actually? How good is it in generating art, in judging art, in being innovative? And I think we've seen a bunch of examples now, and there are many, many, many more, right? We could cover multiple lectures with that. But I just want to give you a few impulses, a few insights on what can be done on that interface. I personally think it's really interesting to see the direction that we're going into. I also have a lot of concerns, to be honest. But I think it's incredible to see where we've come from, right? From these very simple tasks of I'm creating a bird image from a piece of text now to these solutions like DALL-E or Midjourney or video generating solutions. So I'm looking forward to discuss that with you in class and with some examples that you might have. And also to discuss the question, is that creative at all? Does that fit to the definition of creativity that we had in the beginning? But now I'll leave you with that. Thank you for your attention and see you soon.